Hello children, good afternoon, almost good evening. Last time I met you a few days back. Now again I am here in front of you to present another thing in lesson 4, that is presentation of data, mostly diagrammatic presentation of data. We already have explained tabular presentation and textual presentation. Today I will talk about diagrammatic presentation of data. One thing I forgot to mention in my last class while I was explaining the presentation of data, that data, while we are presenting, we can classify them into two types. They are called non-frequency data and frequency data. So for presenting data, before that we are talking about non-frequency data. Non-frequency data and frequency data. Especially when we are talking about graphical presentation or diagrammatic presentation, we have to keep in mind this distinction between non-frequency data and frequency data. But when you are presenting data, especially in tabular form or textual form, that time I should have mentioned it. It was not that essential, but now we are talking about distinction between non-frequency data and frequency data. What's the difference? What's the difference? Well, in case of, before that, I think we need the term frequency. I think this is the new term, frequency. Frequency. What does it mean? Frequency. Frequency. Frequency, you know that how frequently do you come to the class, or how frequently do you saving your beard? How frequently, for the girls, do you go to parlor or here? How frequently? I am using the term how frequently. Here, frequently, frequency, frequent. Adjective, frequent, frequency, noun, frequently, adverb. Frequency is the number of times an event, maybe an incident, value, repeats or occurs. That is the frequency. Say for example, students of arts faculty. We have three faculty, no? Science, arts, commerce, also mass comm. Hello, arts faculty, there may be around this your third semester, maybe around suppose 200 students. If I want to know the average height of all these 200 students, I have to collect the data either from the college office or by some other method like sampling or by complete enumeration. After collecting the data and scrutinization, when I present them in the form of a table, that presentation, that type of data, when I am talking about that average height of the students, remember it, I am interested in average height. Height is the character. Height is the character of the student in which I am interested. And this character, height, is quantitative character, is the quantitative character. Meaning, this character can be expressed in quantitative numbers or terms, and such character which can be expressed in quantitative numbers or terms is called a variable character. Here I am interested to know the average height after collecting the data on heights of you all students of arts faculty. After getting collected data, you students are not at all students, their identification. You Chitan, you Ningma, you Karishma, your identity. Who is Karishma, who is Ningma, who is Chitan, how much your height, they don't matter after getting data collected. Identity of the individuals to which the data relate, identity of the individuals are not important when I am interested to know the average height. Such kind of data which are related to the individuals, their character, their identity of the individuals to which data relate are not important. Those type of data are called frequency data. So remember it, in case of frequency data and non-frequency, that's opposite. In non-frequency data, in this case, identity of individuals, to which data relate are important. That is for non-frequency data. Just opposite, in case of frequency data, identities of individuals, of individuals to which important. Remember it. Remember girls and remember boys. In case of frequency data, after data being collected, after information being collected, after I know everything about you, don't take it otherwise, you are thrown away. Meaning, you are not important. Whatever important your information, your data are taken, that is the frequency data. That is the frequency data. Okay? But in case of non-frequency data, the individuals are important when I am going to present. In case of data, individuals to which the data relate, they are important. Say for example, if you check the data regarding accreditation by NAC, if you check NAC accreditation, if you check pass percentage of different colleges in hills, since you are belonging mostly to hills, and foothills, Sanbigrahi and part of nearby area, even Jalpaiguri, Siliguri and the nearby area, to which you are accessible. So many colleges, suppose there are 15 colleges including St. Joseph's, Southfield College, Darjeeling Government College, Merit College, Sonada College, Jorabangla College, Kalimpong, Krishnam, Siliguri, there are 2-3 colleges are there nearby. And if you check the data, pass percentage and other things to which you are interested, to which you are attracted. Before getting admission into our college, perhaps you didn't check all these things, but you have in your mind, why? Why are you coming to the college? You had thought ours was the best. Your thought. How? Data. What kind of data? Percentage of pass and NAC accreditation, maybe management. What about the characteristics? So when you are checking the data on pass percentage, NAC accreditation, other characteristics, data on such characteristics, on such character, relating to St. Joseph's College, Darjeeling Government College, Christian College, Kalimpong College. Here remember, such data, when you observe, such data are non-frequency data. Such data are non-frequency data. Do you understand? Why? Because this data related to, when you check St. Joseph's College, identity is important. Christian College, identity is important. You cannot wipe by duster the name of this college and see the data only. Useless. For your admission purpose, useless. So all data after getting collected, you have wipe out. Which data relate to which college? If it is not known to you, your purpose or taking admission in St. Joseph's College or in Kalimpong College or in Sanbigrahi College, whichever of your choice, your data is useless if you wipe out the names of the identity of the institution, colleges are wiped out. Here, identity of the colleges, identity of the institution to which data relate, identity are important. Such data are non-frequency data. Such data are non-frequency data. But the data on height of a number of students when I collect, and my purpose is to know the average height. To know the average height, whatever data I collect, data on height figures of all the students. When I collected data, your name was there. After data being collected, your name is wiped out. I don't need. Which data relates to which individual, I am not interested. Identity of the students are not important. Such data are frequency data. Identity important, non-frequency data. Okay? Understood? Next, presentation. Specific graphical presentation. We are talking about graphical presentation of data. Okay? Graphical presentation. It is better to say diagrammatic presentation. Diagrammatic presentation of data. Okay? We have already explained in detail about tabular presentation, textual presentation. Today we are going to explain about diagrammatic presentation of data. Diagrammatic presentation of data. Non-frequency, frequency. We are talking about first non-frequency data. First, non-frequency data we are going to present. Whether it is non-frequency or frequency data, when you are talking about diagrammatic presentation, it has some merits, it has some demerits. All points I cannot remember, but one or two points I can tell you. Diagrammatic presentation. Diagrammatic presentation. Merits. When you talk about merits of diagrammatic presentation, obviously here we say merits mean compared to something else. Compared to something else. So compared to textual presentation, compared to tabular presentation, whatever we have explained already, compared to those, this diagrammatic presentation, important merit, it has ready appeal to an eye. Number one, merits. Ready appeal has ready appeal to an eye. Akhma, that is to the eye, ready appeal. And that's why you'll find in metro cities at night when advertisements are there, models, the pictures are there, drawings are there, paintings are there, with light. They have an appeal. You look. Whether you can read or write, not important. You can see something attractive. So diagram has an attraction. It has an appeal to the eye. be it layman or learned. Be layman or learned. Diagram has an appeal to the eye and get attracted. You being the students get attracted. Especially laymen, they get attracted to the eye. So it is attractive to eye and interesting and attractive to the layman. Second merit. This is very interesting. Second merit. Okay. What is the second merit? Diagrammatic presentation, you can see it reveals many things. It reveals many things which cannot be shown or represented by the tabular method or textual method. How? You think about that. Diagram shows the train, how the train, or you can say change is taking place along with seasonal or cyclical fluctuation. You don't know the term seasonal fluctuation and cyclical fluctuation in data. Actually, when we take time series data, non-frequency data, it may be time series data, it may be spatial series data. It may be, so non-frequency data may be time series data and spatial series data. What are time series data? Data varying over time, meaning population in different years, food production in different years, admission in a college over the years, time. When I collect the data, food production, population, income, or roll strength, over different points of time, different periods of time, over time, the data varying over time, data varying over time, that is called time series data. And spatial series meaning space, varying over space or places. Human Development Index. Have you heard the term? Forget that. Talk about tea production. Where does tea grow in India? Darjeeling Hills, Terai, Doors area, Assam, some part of Karnataka, I think, Nilgiri area. There is also a part of the tea gardens. Sikkim, also there. If I talk about this region, Darjeeling, Terai, towards Assam, Karnataka, Sikkim. Then these 5 places or 4 to 6 places, region, different places. And tea production in different places. I talk about that. If I talk about data, Darjeeling, then Terai, then Doers, then Assam and Sikkim, and then Karnataka. And their production, annual production figure, current year or last year, in 1000 kg. Suppose, I don't know, suppose 50,000 kg, Terai maybe 70,000 kg, Doas I don't know, 75,000 kg, Assam maybe 120,000 kg, Sikkim maybe 20,000 kg, Karnataka maybe around 15,000 kg. These are hypothetical. Remember it, they are hypothetical. These type of data are spatial series data. Spatial series data. Okay? When you present them in the diagram, this individual region, Darjeeling, Terai, Doas, Assam, Sikkim and Karnataka, to which these data relate, identity should be there. Identity are important. Identity should be there in the presentation. We cannot miss them. If we miss them, data are useless. Only thing you can say that, total production. Total is one important figure. If I add this, total figure is important. Otherwise, they are not that important. That's right, identity are important. These data are non-frequency data. These are called spatial series data. Okay? And I already told you what is the time series data? Data varying over time. Suppose role strength in economics. Role strength in economics. Here. Role strength in economics. SJC. Here. This is suppose this 2020, no? Then I'm talking about suppose 2014, 15, 16, 17, 18, 19, 20. And data are hypothetical, I'm assuming 2014, I don't know exactly. I'm talking about all students together, meaning first semester, second semester, and odd semester, first and third together, or part 1, part 2 together, or all students in the department, of economics. I am talking about that. Suppose it was, all students. Suppose it was, I remember, suppose 70, then 65, then 60, then again 75, then suppose 80, and then suppose 87, and this year suppose around 89. This figure, hypothetical figure. But this set of data is time series data. their time 14, 15, 16, 17, 18, 19, 20. These time periods, their identity are not omitted. They are retained. They are important. Without them, these data not that important, useless. Such data together, time series and special series, constitute non-frequency data. And when we present such data in diagram has a ready appeal to the eye. They are very, very attractive to the lay person, ordinary persons. Not only that, diagrammatic presentation, especially when time series data is present, over time when we present the data, we can see the trend, T-R-E-N-D, trend. Trend means what is happening on the average. Trend, it is rising or falling or zigzag, changing, increasing, increasing. Overall, if we check, overall, on level, you just see the trend there. 70, 65, 60, it decreases, again increases. May again fall, may again increase. But over a long period of time, what is happening? That is called the trend. Trend, and this is also called fluctuation. Decrease, decrease. Again increase. In the diagram, increases, decrease, increases, decrease, increases. This is fluctuation. Fluctuation, up, again down, up, again down, up, again down. This change, increase, decrease, this is called fluctuation. And trend, long term. If I talk about beginning and the end, there is an increasing trend. There is increasing trend. So, diagrammatic presentation or graphical presentation shows you the long-term trend along with fluctuation. Increases, decreases, increases, decreases, increases, decreases. This fluctuation. What kind of fluctuation? Now, such fluctuations are different names. I told you seasonal and cyclical. The way it is shown here, it looks cyclical. It looks cyclical over a period of 3-4 years. Over a period of 3-4 years, cyclical. And seasonal fluctuation, you see that generally in West Bengal, there are different seasons. Especially think about puja time. This coming puja within another 15-16 days or maybe a month, not even a month, maybe 20 days left, then the puja season come. This year, unfortunately, because of COVID situation, the Bengali people may not celebrate puja that grand way, but still there will be celebration. And during this time, people wear new dresses, they buy new dresses, new things. Even they paint their houses during Diwali, during Bhai-Tika, they give the gift, they take the gift. But during this period, lots of money are spent by everyone, every family, according to their capability. But whatever they spend, they save throughout the year during puja, they celebrate, buy new things, go to dinner for good things, invite people, they give presentation. All this way, what is happening? What is happening? Demand for the goods, and especially the new garments, demand for new things increase. Or you can say sales of the clothing store, their sales increase. And that happens every year. This puja season, last year puja season, forthcoming following year, next year puja season, it increases, jump takes place. This increase in sales during puja every year, that is called the seasonal fluctuation. Meaning, not in the month of August, July, June, but in the month of October beginning, September end, there is a spot in sales of different goods in the shops. This is seasonal fluctuation. And season generally within a year. Season is within a year. I mean, change within a year. That is also cyclical. When this day, I am talking about from this period to this period, maybe there are so many changes and so many cycles. I am talking about these small changes are seasonal. If I talk about this time to this period is 5 years, there will be 5 cycles maybe. There may be 5 cycles. There may be 5 cycles. 1, 2, 3, 4, 5, like this. The small changes in every cycle, every year, that is called seasonal fluctuation. How can I say that? Sometimes, if you observe carefully some diagrams on a bright light, some small changes, not bright light, low light, some small changes you cannot see. Suppose right now, I cannot see properly because some problem in my eye. I am seeing hazy. So some small changes or some light mark may not be visible to me. As if when you see the broad changes, this is the train. This is also kind of broad change. Cyclical fluctuation is a kind of broad changes over a few years. Within few years, every year there is a cycle within a year. That is called seasonal. Those changes are visible in case of diagrammatic presentation. Another point is that in diagrammatic presentation, if there is any mistake, a certain mistake, if you present in the diagram, that mistake can be detected. Meaning, when you scrutinize the data, somehow you fail to detect the data mistake. Now, in some cases, we present the data, that mistake can be detected. So there are 3 merits I talked about: ready appeal to the eye. Second, it shows the general trend along with some fluctuations, seasonal and cyclical if there. Some details can be shown through the general nature, through the diagrammatic. But, okay, this is some other change, other features can be shown. And third, as I told you that if there is any mistake in the data, that also can be detected, possible to detect through the diagrammatic presentation of data. Now I am talking about demerits. demerits. Demerits of diagrammatic presentation. Actually, yes, demerits means we can say that with respect to the tabular presentation and graphical and textual presentation, there some details or some points to which the writer of the reporter want to draw the attention, or in case of table also some details can be shown in table. That much detail sometimes cannot be presented to the diagram. Diagram gives a general nature of the data with some specific features, as I said, I was technical. That is one. So what is that? Diagrammatic presentations cannot present that much of detail as is possible in case of tabular or textual presentation of data. This is one. Another thing is that, just a minute. Another thing is that yes, another problem is that it is not difficult. Drawing a picture or drawing diagram, it takes time. It takes time consuming. Okay. So in case of textual presentation and tabular presentation, whatever time is spent, much more time is required in case of diagrammatic presentation. These are the two demerits of diagrammatic presentation of data. Okay. Next, I come to the actual presentation of data, that is different types of diagrams. Different types of diagrams. Okay. First, we are talking about time series data. Remember, the diagrammatic presentation of non-frequency data first. Non-frequency data, their presentation. Non-frequency data, their presentation. Presentation, diagrammatic, of non-frequency data. First, number one, we use line diagram. We also use semi-logarithmic chart. Semi-logarithmic chart or ratio chart. We also use, it is rarely used, doubly logarithmic. DOUBL doubly logarithmic. Chart. Rarely used. Rarely used. Fourth, multiple line diagram or multiple axis chart. Multiple axis chart or diagram. Bar diagram. 6 7 divided bar diagram, 8 pie chart. Pie chart. Then maybe another pictogram. 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 Picture. So what are the types of diagram? Now we observe, now we see line diagram, semi-logarithmic chart or ratio chart, logarithmic chart, rarely used, multiple axis chart, sometimes multiple line diagram also used, multiple line diagrams, bar diagram, multiple bar diagram as multiple line diagrams are also possible, divided bar diagram, pie chart and pictogram. In case of line diagram, first we talk about line diagram. Remember, we are talking about non-frequency data. Time series, special series. When we talk about time series data, especially line diagram, we use to represent time series data. Time series data, to represent time series data, we use line diagram. What is that? Draw a line. How? Here we take two rectangular axes of coordinates. Two rectangular axes of coordinates. What is that? So generally we take this way, no? One is vertical axis, another is vertical axis. This is rectangle, right angle, rectangular. We take the first quadrant. Because negative values or negative time we are not taking. That's why we take only the first quadrant. This is called two rectangular axes of coordinates. One is vertical axis, this is vertical axis, and this is horizontal. Two axes of coordinates. Generally we here say x axis and y axis. Here we use the term time on the horizontal axis and value of the variable y t on the vertical axis. Okay, yt. Meaning horizontal is the time, value corresponding to the time t, that is called the value of the variable corresponding to the time t is measured on the vertical axis. Rectangular. You know rectangle, you know that's a rectangular axis, or they are perpendicular to each other. Two axes are perpendicular to each other. Vertical axis, horizontal axis. Here we measure some units. Like say, this is origin O is start with 0, 0, meaning x is 0, y is 0. That is called here time is 0 and the value of the variable is 0 axis. Then generally 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 suppose. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It may be different periods. Maybe say 71, 72, 73 or 2001, 2002, 2003 and so on. Maybe. And you see here, these points are equidistant, meaning unit. Meaning 0 to 1, 1 to 2, 2 to 3, 3 to 4 are equidistant, meaning 2 minus 1 equal to 3 minus 2. Here you can say 2 minus 1 equal to 3 minus 2 equal to 5 minus 4 equal to 1. It means the scale I used is arithmetic. This is called arithmetic scale. This is arithmetic scale. What is that? In case of arithmetic scale, equal distance represents equal differences. Equal distance represent equal differences. Equal distances represent equal differences. Equal distances represent equal differences. Okay, this is the meaning of arithmetic scale. Okay. Similarly, here on the vertical axis 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is also arithmetic scale. Okay. Now, although it is 1, 2, 3, 4, you can take hypothetically different ways. Now, if we, from the actual data, time series data, suppose 2001, in 2001, number of students in our department, how many I don't know, hypothetical value, some figure was there. To draw the line diagram, I have to generate the data. If I take the role strength of economics department over last few years, as I have shown it hypothetically, I forgot the data, again I have to generate, and I can present this here. Okay, suppose the data is like this. Data, there is year and role strength. Year as 15, 2015, 16, 17, 18, 19 and 20. I assume it is suppose 65, 70, then again 60, then again 68, 75, now suppose this is 80. Okay. Now see here, to represent such time series data for 5 periods, here I will take for first period 2015, then 16, 17, 18, 19, 20. And here for 1, 2, 3, 4, 5, I will take for the maximum figure 80, no? 80, how many plus 6? 6 stages 60, 56, 7. Just see here. But each, if I take 10, you can do it. 10, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. Now see here, 2015 is the time. For 2015, your data, the load strength is 65. This is 60 in between somewhere here. So this is a point representing coordinates 15, 65. Like this. This is a point. Maybe point A. For 16, data is 70. 60, 70, exactly here. This is 70. This data is 16, 70. Point B, suppose. Then 17, here 17, data is again 60. Somewhere there, this is the point. Then 18, 18 is 68. 18. 68 is just below 70. Next, 75. 70, 75 in between, somewhere here. Then, which year? 19. What is data? 19 is 75. 20, 80. 20, 80. Approximately here. So we got how many points? Corresponding to how many periods? 6 years. We got 6 data of row strength, and for each pair, time and data, we plot a point, and those points A, B, then C, suppose, then D, then E, and F, to be joined by line segment. We are joining the points by line segment. We get a curve called line diagram. This is called line diagram, and this is the way we draw line diagram. This is called simple line diagram. Remember, when we are drawing this simple line diagram, we are taking arithmetic scale on horizontal axis, vertical scale, that is logarithmic arithmetic scale, also on the vertical axis. Both the axes are arithmetic. Line diagram, simple line diagram, only one. Okay? For this diagram, if you want to show separately girls and boys separately, we can get another diagram for girls, another diagram for boys. Like this. I can say it may be like this. It may be for girls. Similarly, it may get it for a boy. Another boy. You may get a curve for a boy. This type of diagram called multiple line diagram. Here 1, 2, 3. Here we will keep talking about 3 line diagrams together. Multiple line diagram. Multiple line diagrams. Okay? Another important line diagram is there that I will explain tomorrow. That is called, I think, next one is semi-logarithmic chart or ratio chart, and other diagrams. I'll take 1 or 2 more classes. Please bear with me. Thank you so much. for giving your full attention. I hope you understood. If you have any problem in understanding my class or any question you have in your mind, please WhatsApp me, and you know my WhatsApp number. And that answer will be taken, that question will be taken in the next class. Thank you. Thank you so much. Okay, sorry, I took a break. Now I am back. To draw the line diagram, I have to generate the data. If I take the role strength of economics department over last few years, as I have shown it hypothetically, I forgot the data, again I have to generate, and I can present this here. Okay, suppose the data is like this. Data, there is year and role strength. Role strength. Year as of 2015, 16, 17, 18, 19 and 20. I assume it is suppose 65, 70, then again 60, then again 68, 75, now suppose this is 80. Okay. Now see here, to represent such time series data for 5 periods, here I will take for first period 2015, then 16, 17, 18, 19, 20. And here for 1, 2, 3, 4, 5, I will take for the maximum figure 80, no? 80, how many plus 6? 6 stages, 60, 56, 7. Just see here. But each, if I take 10, you can do it. 10, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. Now see here, 2015 is the time. For 2015, your data, the load strength is 65. This is 60 in between somewhere here. So this is a point representing coordinates 15, 65. Like this. This is a point. Maybe point A. For 16, data is 70. 60, 70, exactly here. This is 70. This data is 16, 70. Point B, suppose. Then 17, here 17, data is again 60. Somewhere there, this is a point. Then 18, 18 is 68. 18. 68 is just below 70. Next, 75. 70, 75 in between, somewhere here. Then, which year? 19. What is data? 19 is 75. 20, 80. 20, 80. Approximately here. So we got how many points? Corresponding to how many periods? 6 years. We got 6 data of roll strength, and for each pair time and data, we plot a point, and those points A, B, then C, suppose, then D, then E and F will be joined by line segment. We are joining the points by line segment. We get a curve called line diagram. This is called line diagram, and this is the way we draw line diagram. This is called simple line diagram. Remember, whenever we are drawing this simple line diagram, we are taking arithmetic scale on horizontal axis, vertical scale, that is logarithmic arithmetic scale also on the vertical axis. Both the axes are arithmetic. Line diagram, simple line diagram, only one. Okay? For this diagram, if you want to show separately girls and boys separately, we can get another diagram for girls, another diagram for boys. Like this. I can say it may be like this. It may be for girls. Similarly, you may get it for a boy. Another boy. You may get a curve for a boy. This type of diagram called multiple line diagram. Here 1, 2, 3. Here we are talking about 3 line diagrams together. Multiple line diagram. Multiple line diagrams. Okay? Another important diagram is there that I will explain tomorrow. That is called, I think, the next one is semi-logarithmic chart or ratio chart, and other diagrams. I'll take 1 or 2 more classes. Please bear with me. Thank you so much for giving your full attention. I hope you understood. If you have any problem in understanding my class or any question you have in your mind, please WhatsApp me, and you know my WhatsApp number. And that answer will be taken, that question will be taken in the next class. Thank you. Thank you so much.